Let me start a continuation of the previous lecture. So I want to solve some problems. So cos 2 pi t plus sin 2 pi t, and all these problems I want to solve here. So first problem is cos 2 pi t plus sin 8 pi t. First problem, cos 2 pi t plus sin 8 pi t. Okay. So the question is, find out the fundamental period and fundamental frequency of this entire signal. First of all, is it a periodic signal? So to find that, first I will find T1, that is 2 pi by omega naught. Omega naught is 2 pi here, 1. T2, period of this signal, sin 8 by t, 2 pi by omega naught, 8 pi. This 1 by 4. So one condition to be this entire signal periodic is that T1 by T2 must be rational. Okay, then only periodic. If T1 by T2 is irrational, then not periodic. It is aperiodic. This is periodic. Here T1 by T2 is 1 by 1 by 4 is 4. 4 is a rational number. So what are irrational numbers? Like pi, root 2 or root a, root b, whatever. This kind of numbers are irrational numbers. Okay. Next, so it is a periodic signal because T1 by T2 is not a irrational number, it is a rational number. And what is the period? What is the fundamental period? Fundamental period T of the signal is, so fundamental period means the least period at which this entire signal is repeating. It is least period. It is least common multiple of T1 comma T2. That is LCM of 1 comma 1 by 4. So how to find out LCM of fractions? LCM of numerators by HCF, highest common factor of 1 comma 4 denominators. This 1 by 1. So from this, LCM of 1 comma 1 is 1. Highest common factor of 1 comma 4 is 1. Common factor for 1 and for 4. What is the highest common factor? 1 only. So T equal to 1 is the fundamental period. So what is fundamental frequency? Omega naught is 2 pi by fundamental period 1. That is 2 pi. This 2 pi is the fundamental frequency and T equal to 1 is the fundamental period. Okay. So cos 2 pi t plus sin 8 pi t is the periodic signal. That is repeating with period T equal to 1, which has fundamental frequency is 2 pi. Okay. The next question. The next question, second question, cos 12 pi t plus sin 8 t. Cos 12 pi t plus sin 8 t. So what is T1? 2 pi by omega naught, that is 12 pi. It is 1 by 6. This T2, 2 pi by omega naught, that is 8. That is pi by 4. The condition to check the periodicity, T1 by T2 is equal to 1 by 6 by pi by 4. It is 4 by 6 pi, 2 by 3 pi. Here the term includes pi. Okay, This pi is irrational number. So T1 by T2 is irrational. Then the signal is not periodic. It is aperiodic. Okay. It is not a periodic signal. So it doesn't have any common period. But individually these two are periodic. Cos 12 pi t is a periodic signal. Sin 8t is a periodic signal. But addition of these two periodic signal need not be a periodic signal. But in first case, these two are individually periodic signals, and addition of these two individual periodic signals also lead to periodic signal with a common period t equal to 1. Okay. So addition of two periodic signals is need not be periodic signal. And next, third problem. The third problem is cos 100 pi t, sin 200 pi t, sin 300 pi t. Cos 100 pi t, sin 200 pi t, sin 300 pi t. This is x of t. What is t1? T1 is 2 pi by omega naught, 2 pi by 100 pi. That is 1 by 50. T2, 2 pi by omega naught, 200 pi. That is 1 by 100. T3, 2 pi by omega naught. That is 2 by 3. Okay. So how to check for a period for the signal to be periodic? Condition is T1 by T2 should be rational. T2 by T3 should be rational. And T3 by T1 also should be rational. If these three conditions satisfied, then it is a periodic signal. Check. So T1 by T2 equal to 1 by 50 by 1 by 100. That is 2. This is a rational number. T2 by T3, 1 by 100 by, it is 2 by 300 this one. Okay, not 2 by 3. 2 by 300. That is 3 by 2 is 1.5. 1.5 is a rational number. P by Q form numbers are rational numbers. Okay. And T3 by T1. This is rational, this is rational. And T3 by T1. T3 is 2 by 300. T1 is 1 by 50. That is so 1 by 6, 2 by 6. This 1 by 3. This is also rational number. So the signal x of t is periodic signal. So if it is a periodic signal, what is the period? The period t is least common multiple, because period means at which this entire signal is repeating. The minimum fundamental period means the minimum period at which the entire signal is repeating. How to get the minimum? Least common multiple. Okay. T1, T2, T3. So LCM of what is T1? T1 is 1 by 3. Sorry, what is T1? T1. T1 is 1 by 50, T2 is 1 by 100, T3 is 2 by 300. Okay. T1 is 1 by 50, T2 is 1 by 100, T3 3 is 2 by 300. Okay. So how to find out LCM for fractions? LCM of numerators 1 comma 1 comma 2 by HCF of denominators 50, 100, 300. Okay. What is LCM of 1, 1, 2? It is 2. What is the highest common factor of 50, 100 and 300? Highest common factor. Okay, how to find out? So is there any common factor between all these things? Yes, 50 is there. 50. HCF of 1 comma 2 comma 3. So you can make a common of all these three numbers 50, and then you can find out the HCF of remaining 1 comma 2 comma 3. So what is that? 2 by 50 into what is HCF? Highest common factor 1 comma 2 comma 3. Highest common factor. These three are these three has only one is the highest common factor. That is 1 by 25. This is the fundamental period. T equal to 1 by 25 is the fundamental period. What is fundamental frequency? 2 pi by fundamental period 1 by 25. That is 50 pi. Okay. This is the fundamental frequency omega naught. Fundamental angular frequency, in fact. Okay. This is how you have to solve. The next question 1, 2, 3, 1. And the fourth question cos 60t plus sin 30t. Cos 60t plus sin 30t. So what is t1? 2 pi by omega naught 60. T2 2 pi by omega naught 30. Okay. This pi by 30. T2 pi by 15. What is T1 by T2? Pi by 30 by pi by 15. This 1 by 2 is a rational. Okay. If it is a rational number, then it is a periodic. What is the period? T equal to LCM of T1 comma T2. T1 is pi by 30. T2 is pi by 15. How to find out LCM of fractions? LCM of pi comma pi, the numerators by HCF of denominators 30 comma 50. Okay, so that T equal to LCM of pi and pi is pi. Highest common factor of 15 and 30. So you can make a common of 15 and HCF of 2 comma 1. So highest common factor 1 comma 2 is 1. It is pi by 15. This is the fundamental period. What is fundamental frequency? 2 pi by fundamental period. It is 2 pi by 15. That is 30 radian per second. Okay. Fourth problem completed. Next, fifth problem. This is the fifth problem. 45 plus sin 100 by t. problem 45 plus sine 100 pi t. First of all, is it a periodic signal? Okay, so first I will draw. Sine 100 pi t is the periodic signal. It has, let us say, t equal to 2 pi by omega naught, that is 100 pi, that is 100 pi, that is correct. 1 by 50. Its period is 1 by 50. So how to write? I have to draw sine, this is t, sine 100 by t. Okay, plus 1 minus 1 and so on. This is repeating. And which period is, this is 0, which period is t, 2t minus t minus 2t and so on. Okay, so what is, if we add 45 to this signal? Okay, if we add 45, okay, we'll draw in next slide. We'll draw this in next slide. 45 plus sine 100 by t. Okay, we have to add 45 constant to this signal. Okay, suppose let us say here at t equal to 0, if we add 45 to this signal, here the value is 0. 45 plus 0 is 45. Okay, t equal to 0. Suppose at t equal to t by 4, this is t by 2. T equal to t by 4, we have 1. So if we add 50 at t equal to t by 4, sorry, 45 at t equal to t by 4, we will get 46. Okay, so this entire, let's say this is 45 line, this entire sine wave will be repeating on 50. Okay, this is 46, this is 45, 45 plus 1, 45 minus 1. Okay, but initially it is repeating on 0, it repeating on 0, but here repeating on 55 line. That's it. This is initial case. Okay, this is repeating on 0 line. This is 0 line, but now it is repeating on this 45 line, but it is minus infinity to plus infinity, it is repeating, so that is, it is periodic signal. So addition of a DC value to the periodic signal will not affect uh, in periodicity. So periodicity does not change. What is the period? Period is same as this one. These two have same period. 0, this is t, this is t, time axis. So what is the question? This. So t equal to 1 by 50. So this entire signal also t equal to 1 by 50. Okay, periodicity does not change. Fundamental frequency equal to 2 pi by fundamental period, that is 100 pi. Okay, next. So the problem completed. The sixth problem, e power j 2t plus e power j 4t. Next problem, e power j 2t plus e power j 4t. Same. So for this, t1 is 2 pi by omega naught, e power j omega naught, 2 pi by omega naught. I already derived all these things. Okay. t2 equal to 2 pi by omega naught, 2 pi by 4. This is pi, this is pi by 2, t1 and t2. Sum of these two signals. So t1 by t2 equal to pi by 2. It is 2. This is a rational. So periodic. If it is periodic, what is the period? T equal to LCM of T1 and T2. That is T1 pi and T2 pi by 2. That is LCM of pi comma pi numerator by HCF of 1 comma 2 denominator. LCM is pi. HCF of 1 comma 2 is 1. That is pi. This is common period, common fundamental period, and fundamental frequency is 2 pi by t. 2 pi by pi. That is 2. Okay. The next problem is e power j 2 pi t plus e power j 4t. E power j 2 pi t plus e power j 4t. T1 equal to 2 pi by 2 pi, that is 1. T2 equal to 2 pi by 4, that is pi by 2. What is T1 by T2? 1 by pi by 2, that is 2 by pi. Here pi is there, so it is irrational. It is irrational, so not periodic. If it is not periodic, there is no common period. But individually they are periodic. But addition of these two periodic signals is need not be periodic. The next problem, the eighth one, this one, e power j 2 pi t plus e power j 4 pi t. Okay. Problem, e power j 2 pi t plus e power j 4 pi t. T1 equal to 2 pi by 2 pi. I already done all these things. 2 pi by 4 pi. It is 1 by 2. This is 1. So T1 by T2 equal to 2. Here rational. So period is periodic. Period is LCM of T1 and T2. That is T1 1, T2 is 1 by 2. That is LCM of 1 comma 1 by HCF of 1 comma 2. That is 1 by 1. That is 1. And what is omega naught? 2 pi by t. This is the fundamental frequency. Okay. So the next question, the last one. Here I will do here itself. 100 plus cos 50 pi t plus cos 100 pi t plus sin 102 pi t. First of all, cos 50 pi t, cos 100 pi t, sin 200 pi t. This is a periodic signal. Addition of these three signals. Plus some DC value is added. Okay. Addition of DC value does not change the periodicity. So what is T1? Cos 50 pi t. So 2 pi by omega naught 50 pi. That equal to 1 by 25. T2 2 pi by omega naught 100 pi. That equal to 1 by 50. T3 2 pi by omega naught 200 pi, that is 1 by 100. So if you check T1 by T2, T2 by T2 by T3 and T3 by T1, you will get irrational numbers. So it is a periodic. That period is LCM of T1, T2, T3. That is LCM of 1 by 25, 1 by 50, 1 by 100. Okay, you can do it on your own. Not a big deal. LCM of numerators by LCM of HCF of denominators. What you get HCF? 25, 50, 100. Highest common factor you will get 25 only. Okay, 1 by 25 t equal to, I will write here it's 1 by 25. Okay, so why I gave these kind of problems here? Because I want to give some inferences. Okay. Here, so in the argument cos 2 here, cos 2 pi t sin 2 pi t is there, so it is a periodic. But in this case, cos 12 pi t 8t, here pi is there in this argument. In this argument, pi is not there, so it is not periodic. You don't need to solve, just check it whether pi is there in both the signals or pi is not there in both the signals, or pi is there in one signal and pi is not there in other signal. So if pi is there in one signal and pi is not there in another signal, then it is a not it is a aperiodic signal. Okay. If pi is there in all the signal, it is a periodic. If pi is not there in all the signal, it is also periodic. Okay. One contains pi and another contains no pi, then it is not a periodic signal, aperiodic signal. Okay. In this case, third case, pi is there, pi is there, pi is there, so it is a periodic signal. Here pi is not there, pi is not there, fourth one, so it is a periodic. Pi is not there in both the case. Okay. This is the fifth one is a DC value. Addition of DC does not change. Okay. Anyway, this one is single signal, so it is a periodic, sin 100 pi t. Here also e power j2t, e power j4t, so pi is not there in both the signals, so it is a periodic. In seventh, 2 pi is there, here 4 is there, so pi is there here, pi is not here, so it is not a periodic. And eighth one, pi is there, 4 pi is there, so pi pi is there, pi is here, so pi is there in both the signals, so it is a periodic. And ninth one, pi is there, pi is there, pi is there, so pi is there in all the signals, so it is a periodic. So you have to check whether pi is there in all the signals or pi is not there in all the signals, or pi is there in one signal and not in other signal. That's it. Okay. And some more problems on discrete time signals. I will do these things in here itself. So first problem, let us say n1. I want to find out n1. How to find out n1? But here the additional constraint is, so the n must be integer. The period of the signal is integer because it is a discrete time signal. So the sequences are integers. Okay. The n, let us say n1 equal to 2 pi by omega naught into k. I already derived this. 2 pi by omega naught is 100 pi into k. Okay. So k by n1, let us say n1 equal to 2 by 100 to k, that is 1 by 50 into k. Okay. For what value of k, n1 is an integer. And the two, that integer value must be at least value. Okay. So for what value of k, we will get least integer value. So k is 1, 2, 3. K is also integer. Okay. For k equal to 50, n you will get 1. Okay. Otherwise, I will write this like k by n1 equal to 50. That equal to 50 by 1 I can write. So for k equal to 50, n1 equal to 1. This is the minimum value. Okay. So n1 equal to 1. This is the fundamental period of this one. And this one, n2 equal to 2 pi by omega naught 50 pi into k, that equal to 1 by 25 into k, and k by n2 equal to 25 by 1, and for k equal to 25, n2 equal to 1, that is the integer, so n2 equal to 1 for k equal to 25. Minimum integer value is 1. Okay. So this is the fundamental period of the cos 50 pi n. Cos 50 pi. So the periods of 2 came, and we don't need to check n1 by n2 is irrational. The rationality of n1 by n2 need not to check because these two are already integers. Because we already put some constraint on n, that is they are integers. So integer by integer always is always rational. Okay, so we don't need to check. So once n1 n2 you got, it is a periodic. So what is the period? N equal to same LCM of n1 comma n1 n2, because we need least common multiple, least integer value we need, that to common to both the signals. Okay, that is LCM of n1 is 1, n1 is 1, n2 also 1, so you'll get 1. N is 1. Okay, common period is 1. So next question. The next question is, e power j 25 pi n plus e power this one, e power j 25 pi n plus e power j 100 n. E power j 25 pi n plus e power j 100 n. So by looking this, I can easily say it is not a periodic signal because pi is there here and pi is not there, so it is not a periodic. So n1 equal to 2 pi by omega naught into k. So k by n1 equal to 25 by 2. For k equal to 25, n1 equal to 2. Okay. So least integer we get is 2. This is the period of first one. And the second one, e power j 100 n. This one. So let us say n2 equal to 2 pi by omega naught into k. K by n2 equal to 100 by 2 pi, that is 50 by pi. This is not rational. So you won't get integer here n2. For what value of k? K must be integers. For whatever the value of k, you won't get integer. So that is why irrational. So this is not a periodic. This omega naught n is not periodic. If it is not periodic, the entire signal is not periodic. Okay. Periodic plus not periodic signal is always non-periodic. So entire signal is aperiodic. Okay. So for these kind of signals, you have to check whether pi is there, pi is not there. That's it. Okay. I have discussed enough on periodicity. Then I will go to the next classification. Next classification is so the classification. Next classification is real and complex valued signals. Okay. Anyway, I will discuss it at the last. So next I will discuss the seventh one. This one. This is power and energy signals. Okay. First I will discuss this and then I will go to real and complex valued signals. Okay. Power and energy signals. The seventh classification. Okay. Seventh classification is power and energy signals. Okay, first I will define energy signal. The signal which has finite energy. Okay, this is called energy signal. So how to calculate energy? So we want to find out whether the energy is finite or infinite. So how to calculate that energy? Energy of the signal is integral over minus infinity plus infinity. This is energy of the signal x of t. It's magnitude whole square dt. This is energy of the signal. Okay, whether x of t is a real signal or a complex signal. This is the magnitude whole square dt. Okay, so this must be less than infinity. Okay, some finite value. Then it is energy signal. Okay, next power signal. What is power signal? Same definition. A signal x of t which has finite power. The power is finite. So how to calculate power? Whether it is finite or infinite. So power equal to 1 by t integral of minus t by 2 to plus t by 2 magnitude of x of t whole square dt. This is for periodic signals. This formula is for periodic signals. Okay, and p equal to limit t tends to infinity 1 by t integral of minus t by 2 to plus t by 2 magnitude of x of t whole square dt. This is for aperiodic signals. Okay, so power exists for both periodic and aperiodic signals. If it is periodic signal, the formula is this one. There is no limit t tends to infinity because for periodic signals, the average power. This is average power. So it is repeating. So what you get on average? On average, you will get. So if you calculate for one period, then you will get same for entire signal. Okay. Similarly, for aperiodic signal, it is not repeating. Okay. So that's why here the limit t tends to infinity. 1 by t minus t by 2 plus t. These are the formula. So these formulae are important. Okay, in communication also. So this must be finite. This p is p less than infinity. That is finite. Then it is a power signal. Okay. And one more formula I want to give you. What is power? Power is energy by time or rate of change of energy by time dE by dt. That is power. Power is related with energy. That is P equal to dE by dt, rate of change of energy. Okay. For energy signal, energy is less than infinity. That is some finite value. Okay. So I want to calculate power of energy signal. Okay. Power of energy signal. I want to calculate this one. I'm interested in this. let us say how to calculate power equal to 1 by t integral minus t by 2 to plus t by 2 limit t tends to infinity magnitude of x of t whole square dt. Okay, but limit t tends to infinity 1 by t, this term is energy minus t by 2 plus t by 2 x of t whole square dt. This term is energy. Okay, power equal to energy by time. That is what I have written here, energy by time. Okay, so this is some finite value, limit t tends to infinity. Energy is finite here for energy signal, some finite value by t. Okay, this is some finite value by t, but here limit t tends to infinity, then what you get? 1 by infinity 0. Okay, so this is one important consequence. So power of energy signal is 0. Equal to 0. Okay, similarly I will find out energy of power signal. So I want to find out energy of power signal. So for power signal, power is finite. P is finite. Okay, P is less than infinity. So energy equal to integral of minus infinity to plus infinity magnitude of x of t whole square dt. Okay, so the power is limit t tends to infinity 1 by t integral of minus t by 2 to plus t by 2 magnitude of x of t whole square dt. So this total value is finite. This total value is some finite. What if it is finite? What is E? Okay, P equal to limit t tends to infinity 1 by t. What is this value? This value is energy. Okay, so this value should be finite. Okay, so E by t, limit t tends to infinity. Even though if you substitute infinity, so I will substitute infinity here, E by infinity. Here you will get a 0. Okay, power should not be 0 for power signal. Okay, if it is 0, it is energy signal. If power is 0, I already derived this. So if power is 0, it become energy signal. So E by infinity should be finite value. Okay, then at what case you will get finite value? If E also infinite. Okay, if E equal to infinite, you will get infinity by infinity form. Then what you have to do? L'Hospital rule. If you do L'Hospital rule, then you will get some finite value. Okay, so that is why then you will get some finite value, power equal to finite. So that is why energy of a power signal, this energy of a power signal is infinite. Energy of a power signal equal to infinite. So it is common sense, because power signal has to supply power from minus infinity to plus infinity. Okay, so if you integrate minus infinity to plus infinity any signal, you will get infinity only. Okay, so that is why energy is infinity for power signal. Okay, one more definition here. Neither energy nor power signal. Nor power. So it P equal to infinity, power equal to infinity, energy equal to infinity. Then the signal is called neither energy nor power signal. Okay. Both are infinite. That is P equal to 1 by T, limit T tends to infinity, integral of minus T by 2 to plus T by 2, x of T whole square dt. This energy is integral of minus infinity plus infinity, magnitude of x of T whole square dt. So these both are infinity. Okay. Then it is a neither energy nor power signal. I will give some examples for this kind of signals also. Okay. Some examples. So I will give one example like discuss some u of t, some a times u of t. Second one, constant a. Okay. Third one, e power minus 2t into u of t, exponential signal. Fourth one, some a cos omega naught t. Fifth one, some a sin 100 pi t plus b cos 50 pi t. Some sixth one, a power 2t into u of t, and seventh one, del of t, and eighth one, r of t. Okay, so these are some signals, and these are useful signals. Okay, that is why I gave you. I will find out whether these are energy signals or power signals. My question is whether the above are energy or power or neither energy nor power. This is my question. Okay. If it is energy signal, find out its energy. If it is power signal, find out its power signal. If it is neither energy nor power signal, prove that their energy and power both are infinity. Okay. This is what we have to do. The first question, a times u of t. First, a times u of t. This is the step size is a. Step signal. So how to write? How to draw? Let's see a times u of t. This is t. This is a, and 0 for t less than 0. Okay. This is a times u of t. So in this case, so it looks like constant signal. So 0 to infinity. So let us say I will assume that this is the power signal, and just assume. You can assume it as energy signal also. If you assume this as energy signal, if you get energy is infinite, then check again by assuming it is a power signal. If then also if you get the power is infinite, then it is neither energy nor power signal. If you get power as finite, it is a power signal. Okay. So in the first case itself, if you assume then it is an energy signal, in the first case itself, if the energy comes as finite, then it is energy signal. I am assuming that it is a power signal. That's it. Okay. And it is not a periodic signal. Okay, remember. So I am assuming that it is a power signal. So if it is a power signal, I have to show that its power is finite and its energy is infinite. So power equal to finite and its energy is infinite. Okay, I have to show this. I will take this as minus t by 2, this as plus t by 2. Remember, the signal is present from minus infinity to plus infinity. So minus infinity to 0, it is 0. 0 to infinity, it is a. So you have to take both the negative and positive values. Okay, this is important. You cannot take only positive side. Okay, you cannot take only negative side of the signal. So you have to take both negative and positive side of the signal. Okay, this is important. So what is power formula? Limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2 magnitude of x of t whole square dt. So this is limit t tends to infinity 1 by t integral of minus t by 2 to 0, we have 0, plus 0 to t by 2 we have a, and squaring a square dt. Okay, so limit t tends to infinity 1 by t, this term is 0 and this term a square into t by 2. Limit t tends to infinity, t gets cancelled, you will get a square by 2. Substitute t equal to infinity. Here no t is there, so a square by 2. So we are getting power equal to a square by 2, which is finite. So it is a power signal. Okay. Okay, I'm assuming power signal. So it is I got power is finite. So it is a power signal. Okay. And what you have to show, its energy should be infinite. How to show that? What is energy formula? Energy equal to integral of minus infinity to plus infinity magnitude of x of t whole square dt. Integral of minus infinity to 0, that x of t is 0, 0 square plus dt. So 0 to infinity, it is a square dt. Okay, magnitude of a is a only. So a square into this term anyway 0, this term a square into t, we have to substitute limits 0 to infinity. A square into infinity, you will get infinity. So energy is infinite. Power is a square by 2, that is finite, and the energy is infinite. Then it is a power signal. Or step signal is a power signal. Okay. And the next question is constant a. So how to represent constant a? This is this one. It is constant throughout the time. Okay, minus infinity to plus infinity is constant. This is x of t. Is a. So this also, for me, it is looking like power signal. I'm just assuming is a power. So let us say power signal. Assume. So if you assume power signal, you have to find out the power. Power equal to limit t tends to infinity 1 by t integral of minus t by 2 to plus t by 2 magnitude of x of t whole square dt. So I will say this is minus t by 2, this is plus t by 2. Let us say. So at minus t by 2 to plus t by 2, you have value a. Limit t tends to infinity 1 by t integral of minus t by 2 to plus t by 2, we have value a square dt. Okay, so that is limit t tends to infinity 1 by t a square into t. We have to substitute the limits minus t by 2 plus t by 2. That is limit t tends to infinity 1 by t a square into t. That is a square. Dt gets cancelled. So power is a square. We got finite. To calculate energy integral minus infinity plus infinity a square dt, you will get infinity. So it is a power signal. Therefore, it is a power signal. So this is a constant signal or DC signal. Okay, DC signal is a power signal. And in the previous case, here we got the power. Power is a square by 2. Okay, because u of t is present only positive half of this positive half. But here the signal is present both the halves, negative half and positive half. So here power equal to a square. There power equal to a square by 2. Okay. Next question. So this is why this came. I will discuss because these two are orthogonal signals. I discuss that anyway. The next problem is e power minus 2t into u of t. This one. Third one, e power minus 2t into u of t. You will draw the signal also. So you are multiplying with u of t means only positive side of the signal. Okay, negative side of the signal is 0. You will draw this like this. And at t equal to 0, you have e power minus 0 into u of 0. T equal to 0 is 1. And for t less than 0, this is 0 because we are multiplying with u of t. U of t is 0 for t less than 0. And this is 1 at t equal to 0. And if t tends to infinity, e power minus infinity is 1 by e power infinity, that is 1 by infinity. E value is approximately 2.72, so 1 by infinity is 0. At t tends to infinity, this becomes 0, so it is exponentially decreasing. This is the signal. So I want to find out the energy of the energy or power, whatever. If energy signal, you have to find out energy. If it is power signal, you have to find out the power. So it looks like it is not a constant signal for me. So I am assuming that this is energy signal. Let energy, assume energy, because it is not constant and it is not periodic. That is why I am assuming energy signal. So if it is energy signal, let us say E equal to finite, minus infinity to plus infinity, magnitude of x of t whole square dt. That equal to, from minus infinity to 0, the signal is 0. For 0 to infinity, the signal is e power minus 2t dt. Okay. Or you substitute here itself, integral minus infinity plus infinity, e power minus 2t into u of t whole square dt. Okay, so from here itself u of t is 0 for t less than 0. These are limits, t limits. So until minus infinity to 0, this value is 0. 0 to infinity, we have u of t is 1. So 1 into e power minus 2t. And that is what I have written here. E power minus 2t whole square. So that is 0 to infinity e power minus 4t dt. Integrate. This is e power minus 4t by minus 4 integral of 0 to infinity. Limits are 0 to infinity. So I'll write this here. Substitute limits. E power minus infinity value is 0 and e power 0 value is 1. So minus 1 by 4 e power minus infinity 0 minus e power 0 value 1. That is 1 by 4. This is the energy. We got energy is 1 by 4 finite value. So it is energy signal. Okay, energy signal. So, and one more, you have to show the power of the energy signal is 0, right? So power P equal to, how to get 0? The signal itself, power equal to 1 by t limit. It is not a periodic signal, so 1 by t limit t tends to infinity minus t by 2 to plus t by 2 magnitude of x of t whole square dt. Okay, so this signal limit t tends to infinity. So if you substitute t tends to infinity here, this become minus infinity, this will become plus infinity. So limit t tends to infinity 1 by t minus infinity plus infinity x of t whole square dt is energy of the signal, energy. And you got energy is finite, that to 1 by 4. Limit t tends to infinity 1 by t into 1 by 4. So if you substitute t tends to infinity, you will get 1 by infinity into 1 by 4, that is 0. So this is energy signal and the power of energy signal is 0. Okay. E power minus 2t of t is the energy signal. And a cos omega naught t. So a cos omega naught t. Omega naught t is a periodic signal. Okay. All periodic signals are power signals. Okay. So that's it. So we can prove this. A cos omega naught t. X of t equal to a cos omega naught t. Okay. Where time period t equal to 2 pi by omega naught. Okay. So it is a power signal. How to find out the power of the signal? Power equal to 1 by t integral of minus t by 2 to plus t by 2 a square cos square omega naught t dt, where t is a 2 pi by omega naught. 1 by t a square by t integral of minus t by 2 to plus t by 2 cos square theta 1 plus cos 2 theta by 2. This is dt. This is a square by t 2 also here, and integrate this one plus t plus this one cos 2 omega naught t is sin 2 omega naught t by 2 omega naught, and substitute the limits minus t by 2 to plus t by 2, and that equal a square by 2t into. So first substitute t by 2 minus t by 2 here itself at t. You will get t by 2 minus of minus t by 2, you will get t. Okay, directly substituted here at t plus t by 2 minus of minus t by 2, you will get t. Next here I'll substitute t by 2 first. So 1 by 2 omega naught sine 2 omega naught into t by 2 minus 1 by 2 omega naught sine minus 2 omega naught into t by 2. Okay, so if it is not visible, I will write again this, or I will write in the next slide if it is not visible. Okay, I'll write in the next slide. So it is a square by 2t into t plus sine 2 omega naught t by 2 omega naught minus t by 2 to plus t by 2. So first I will substitute t by 2 here itself. A square by 2t plus 2 by 2 minus t by 2 will get t. Next a square by 2t into this sine 2 omega naught capital T by 2 by 2 omega naught minus sine 2 omega naught minus T by 2 by 2 omega naught. So what is this value? Sine of 2 omega naught into T is 2 pi by omega naught into 2. This omega naught cancel. Sine 2 cancel, sine 2 pi. Okay, sine 2 pi value 0. Here also we will get sine of minus 2 pi. This value is 0. So this entire term is 0. So we have only a square by 2t into t. It is a square by 2. This is the power of the a cos omega naught t or a sin omega naught t for both the cases. Okay. So for a cos omega naught t, power is a square by 2. For a sin omega naught t also a square by 2. And get the same thing. And here a sin 100 pi t plus b cos 50 pi t. Okay. So this has power. Here I'll write here itself. A sin 100 pi t plus b cos 50 pi t. So these are RMS values. First we had to calculate RMS values. What is the RMS value of this one? A by root 2. This for this a by root 2, for b cos 50 b by root 2. Square root of RMS values. Or you directly write a square by 2. This has power and this has power b square by 2. You can add both. Okay. Why? Because sin 100 pi t and cos 50 pi t are orthogonal signals. So if they are orthogonal signals, there you can add their powers. Okay. The cross term. Okay. If you want to find out the power, you have to whole square it. Integral minus t by 2 plus 2 by 2. If you whole square it, you will get a square sin square 100 by t, b square cos 50 by t. In these two cases, you will get a square by 2 plus b square by 2. But one more term, the cross term, 2ab sin 100 by t cos 50 by t. Because sin 100 by t and cos 50 by t are orthogonal signals, you will get integration of sin 100 by t into cos 50 by t, you will get 0. Because these are orthogonal signals. Okay. I will discuss this when I discuss the Fourier series. That is why I am adding their powers. Okay. That's it. Power of a sin 100 by t plus b is cos 50 by t. And sixth signal e power 2t of t, seventh del of t, eighth r of t. Okay, these three signals are, let's discuss. What are these three signals? So first, sixth one. Where is the sixth one? We shall draw the signal. How it is there? This is t. We are multiplying with u of t. So only positive side of the signal is present. Negative side we have to multiply e power 2t with 0. So we don't have a negative side signal. So at t equal to 0 we have 1, e power 0 1, and at t equal to infinity, e power infinity value is infinity. So we will get 0 less than 0, and you will get infinity t equal to infinity. This is increasing exponentially. Okay, so exponentially rising signal. So these kind of signals are neither energy nor power signals. So first calculate this energy. Energy equal to integral minus infinity to plus infinity x square of t e power 2t into u of t whole square dt. What do you get here? Because of this u of t, you have limits only 0 to infinity, and your squaring is e power 4t dt. So e power 4t by 4 integral of 0 to infinity. First, if you substitute t in place of t infinity, you will get infinity itself. Minus 0, e power 0 is 1, that is infinity. So you got energy infinity. So if energy is infinity, okay, next calculate power. Power equal to limit t tends to infinity, my 1 by t minus t by 2 to plus t by 2 magnitude of x of t whole square dt. Okay, so limit t tends to infinity. I will specify the limits. Here let us say minus t by 2 plus t by 2, 1 by t. From minus t by 2 to 0 you don't have signal, 0. So from 0 to t by 2 we have signal e power 2t into u of t. And for 0 to t by 2 we have e power 2t into u of t value is 1 for 0 to t by 2. Okay, whole square dt. Limit t tends to infinity, 1 by t integral of 0 to t by 2 e power 4t dt. Okay, and equal to limit t tends to infinity, 1 by t e power 4t by 4 0 to t by 2 that equal to e power 4 t by 2 by 4 4t limit t tends to infinity. Okay, so as this power equal to e power 4 t by 2 to 4t limit t tends to infinity. What you get limit t tends to infinity? If t tends to infinity, e power infinity by infinity, by infinity by form. So if you get infinity by infinity form, what you have to do? You have to do L'Hospital. So differentiate numerator and denominator with respect to capital T, with respect to t. Okay, e power 4t by 2 into yeah, that's correct. E power 4, e power 2, okay. E power 4 divided into 4 by 2 by 4, and again apply limit t tends to infinity. Then what you get? This is 1 by 2 into e power infinity. I'll get infinity. So power equal to infinity and energy equal to infinity. So the e power 2t into u of t is neither energy nor power. Okay. Similarly, we'll discuss next signal. Next signal is del of t. Seventh one. Del of t. For x of t is del of t. So what is this? Is it energy signal or power signal? Okay, we'll draw this. At 0 we have, this is the signal. At 0 we have infinity. I'll write the mathematical expression also. Infinity at t equal to 0 and 0 at t not equal to 0. Okay, and integral of minus infinity plus infinity del of t dt equal to 1. Area under this curve is 1. So from these definitions, okay, let us say I want to find out, I'm assuming that it is not a constant signal, so I'm assuming that it looks like energy signal. I'm assuming that it is energy signal. So then I will find out energy. Energy equal to integral of minus infinity plus infinity magnitude of x of t whole square dt, that equal to integral of minus infinity plus infinity del of t whole square dt. I will write this integral minus infinity plus infinity del of t into del of t dt. Okay. So one of the property of del of t is, suppose some del of t into some x of t. Okay. Then so del of t exists only at t equal to 0. Okay. Otherwise zeros. So we are multiplying del of t with x of t. So only at t equal to 0 only signal exists. So all other cases this product is 0. So I will write this as del of t into x of 0. Okay. All other values of t, whatever may be the x of t, you have to multiply with 0 only, because del of t is 0 for all other values of t equal to 0. Okay. So del of t into x of 0. This is one of the property, and I will discuss when mm, I start linear time invariant system. Yeah, these all properties. Okay. So here del of t into del of t. Then how to write this? This one, not equal to integral of minus infinity plus infinity. Let us say one is del of t, one is some x of t. Okay, it's del of t. I will write del of t into x of 0. So x of t, x of 0, that is del of 0, and integral minus infinity plus infinity del of t into what is del of 0 at t equal to 0. What is del of 0 value? Infinity. So infinity. You are multiplying any signal with infinity, you will get infinity. So energy equal to infinity. Similarly, you will get power also infinity. Similarly, power limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2 magnitude of x of t whole square dt. So we can specify the limits also. Let us say minus t by 2 plus t by 2. Okay. So limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2 del of t whole square. I will write del of t into del of t dt. Okay. Limit t tends to infinity, same. Integral minus t by 2 to plus t by 2. This one of the signal is x of t, then x of 0 into del of t dt. But this value is infinite. Limit t tends to infinity 1 by t integral minus t by 2 to plus t by 2 infinity into del of t dt. What you get? You multiply with infinity into limit t tends to infinity 1 by t integral of minus t by 2 to plus t by 2 del of t dt. Okay, infinity is not a function of time, so that is why I can bring this outside. Okay, this value, what you get? Area minus t by 2 plus t by 2 del of t dt is 1. This is 1. So this term is 1 area property and 1 by t. Okay, some finite value. Uh, so some finite value. Okay, infinity by t. Oh, sorry, infinity by infinity form. You are getting here infinity by infinity. So limit t tends to infinity. Infinity into 1 by t. Okay, or you can write infinity into whatever may be the value you get. So here the infinity we got, is not because of this limit. Okay, not because of this limit. Here itself we can say infinity into entire signal, entire anything, infinity into anything I can say here itself. So you don't need to come here. So here itself infinity into anything, whatever this value is infinity. So that is power equal to infinity. So both energy and power are infinity for del of t. Therefore, power equal to infinity, energy equal to infinity for del of t. That is, del of t is neither energy nor power. Okay. The next signal, last one, is R of t. R of t, that is ramp signal, that is t into u of t. Find out energy, integral minus infinity plus infinity t into u of t whole square dt. That is, because of u of t you only have limits 0 to infinity, that is t square dt is t cube by 3, 0 to infinity you will get infinity. Its energy is infinite. Similarly you will get power also infinite. So that is R of t. You can easily find this power. So R of t is neither energy nor power. Okay. Yeah, I think I have discussed enough on energy and power signals. And this orthogonality condition I'll discuss when I start the Fourier series. Okay. The last classification is there. Uh, the last classification is sixth classification, real and complex valued signals. This is the last classification of signals. Okay. I will discuss it later in the next lecture. Okay. I'm going to stop.